Hello viewers, in today's class we are going to discuss an important problem from limits involving signum function, right? So here we have to find the value of this limit, that is limit x tends to 1 and signum of x minus 1, right? Now before solving this problem, let us first see the definition of signum function, right? And then we'll see the criteria for limit of a function to exist. So let us first see the definition of signum function, and we know that signum of x, uh, it is defined like this. Signum of x would take the value plus 1 whenever x is greater than 0, right? And the signum of x would take the value 0 whenever x is equal to 0, and signum of x would take the value minus 1 whenever x is less than 0, right? So this is the definition of signum function, and we know that the domain of signum function is the set of all real numbers, and the range is 0, plus 1 and minus 1, right? Okay, so once we have seen the definition of signum function, let us see the criteria of limit of a function to exist. Now let us consider a function, say y is equal to f of x, right? And this function is defined on some domain, and if we take some point x is equal to a in its domain, then we say that the limit of this function exists when x tends to a if the left hand limit and the right hand limit of this function both are finite and equal, right? Then we can claim that the limit x tends to a of f of x exists, right? So here we have to find the value of this limit, but before finding out the value of this limit, let us first find the left hand limit and the right hand limit for this function, right? So now what we will do, we'll take the left hand limit, and here for the left hand limit the notation is the limit x tends to 1 minus, right? So we'll put a negative sign over 1 to indicate that we are calculating the left hand limit, and here we'll write the function, right? Okay, so now here we have the number line, and here we have the point x is equal to 1, right? So when we approach from left of x is equal to 1, it means we are calculating the left hand limit, and when we approach from the right of x is equal to 1, it implies that we are calculating the right hand limit. So now this is the notation for the left hand limit. So what we will do, we'll take x is equal to 1 minus h, right? And here we are taking x is equal to 1 minus h because we are approaching from the left of x is equal to 1. And remember, this quantity h is a very small quantity, right? And it lies between 0 and 1. And we can also say that this quantity h is a positive quantity, right? So we can take here x is equal to 1 minus h. So now when x tends to 1, obviously h tends to 0, right? So now this left hand limit takes the form limit h tends to 0, because for x tends to 1 minus we can replace it by h tends to 0, and then we have signum of x minus 1, right? And for x we can write 1 minus h, and then we have minus 1. So we can simplify it. So we have limit h tends to 0, signum of minus h, right? So this one and this one get cancelled, and we are left with signum of minus h, right? Now here we cannot directly substitute h is equal to 0, right? So here comes the role of the definition of signum function, right? See, h is a positive quantity, right? and here we have minus h. So minus h is a negative quantity, right? And whenever we have any negative quantity inside this bracket, so then we have signum of say negative quantity, right? So whenever x is less than 0, x less than 0 implies that we are dealing with the negative numbers, right? So signum of negative always gives us the value -1, right? So signum of minus h gives us the value -1, right? So here we'll have the -1, and now this is equal to -1. So the left hand limit of this function is -1, right? And similarly we can calculate the right hand limit, and the right hand limit is the limit h. Here we can take x tends to 1 plus the positive sign shows that we are calculating the right hand limit, and here we have signum of x minus 1, right? So following the same lines, we can now write x is equal to 1 plus h, right? Because in this case we are dealing with those values of x which are greater than 1. That's why we have 1 plus h, and h is a positive quantity here, and it is a very small quantity, right? So now when x tends to 1, h tends to 0, right? So the right hand limit is equal to limit h tends to 0. We have signum of 1 plus h minus 1, right? So this x is now replaced by 1 plus h. This -1 and 1 get cancelled. We are left with limit h tends to 0, signum of h, right? And again, as we have discussed earlier, we cannot directly substitute here h is equal to 0, right? Because here this h is a positive quantity, and since h is positive, so signum of positive gives us the value +1, right? See, here we have x greater than 0. It means we are dealing with the positive numbers. So signum of positive gives us the value +1. So here we have limit h tends to 0, positive 1, that is equal to +1, right? So now we see that the left hand limit is -1 and the right hand limit is +1, and these two limits are not equal, right? So although the left hand limit is finite and it exists, similarly the right hand limit is finite and it exists, but both the limits are not equal. So we claim that the limit of this function does not exist as per our this definition, right? So this is how we can solve these type of problems, right? We can also solve this problem by another method, and we can discuss that method in our next video.